Hello everyone. Today we're going to be going over homework number 4, page 33, unit 4B. And here's our first problem. It says that a 4,500 kilogram helicopter is accelerating upward at 2 meters per second squared. Calculate the upward force provided by the propellers to achieve this acceleration. Okay, first off, we simply need to find the amount of force we need so that we provide just enough force so that it doesn't move. It doesn't go up or down. That we need to calculate force weight, which, by the way, is given to us as force weight equals mg. Now, calculating that in, we get 4,500 kilograms times 9.8 meters per second squared equals 44,100 newtons. Now, that's force weight, and in turn, that's force up, aka the amount of force you need just to break even. But we are moving the helicopter upwards at 2 meters per second squared. We need to add that in as force applied, which is 4,500 kilograms times 2 meters per second squared, which again is mass times acceleration. And that's 9,000 newtons. And we need to add both the numbers together because remember, we need the force just enough to break even and the force to pull it upwards. And we add the two numbers together and we get 53,100 newtons. Okay, now for problem 2. This is a slightly more difficult one. And the problem says, a 9.05 kilogram picture is held against the wall with a force that is 40 degrees from the vertical. Determine the magnitude of the minimum force required to prevent the picture from sliding down the wall if the coefficient of static friction between the wall and picture is 0.560. Okay, first off, we need to draw a diagram. A diagram is very helpful to this, and apologies for my very tiny handwriting, but I don't know if you can see it, but there's the drawing in all of my work. But as you can see, this 9.50 kilogram object, okay, we draw the basic picture and be careful of the problem asking because it says 40 degrees from the vertical and 40 and 50 are complementary. So I wrote 50 degrees right here. And now the next step is to draw up all our forces. The only force that is going against us is force weight. Remember, we are just holding the object just enough so that it doesn't fall. So force weight comes down, it's against us, and this is us pushing the object, and we have force of sine 50 degrees because remember, sine is opposite over hypotenuse, so force sine 50 degrees. And force friction is actually with us because it's helping us prevent the object from falling down in this case. And obviously this is just force because relative to them, it's just force. And that's why you have force sine 50 degrees. And if you remember what we learned, that force normal is always perpendicular to the object, being perpendicular to the object and the surface. So force normal is pushing towards the left like that. And force cosine 50 is that way because, again, force, you split the force into sine and cosine is adjacent over hypotenuse, and that's how we get that. Now, now it's time to set up the equations from right here, okay? Since we're trying to find the difference, the amount of force we need to make force weight equal force friction plus force sine 50. Again, this is just enough force to prevent the object from falling down as it's asking. So force sine 50 plus force friction equals force weight. Now we know that force weight equals mg, and g is obviously 9.8 meters per second squared. Our mass is 9.05 kilograms, and plugging that into our calculator, we get 88.69 newtons for force weight. Now we need a little bit of substitution, because we already know that mu equals force friction over force normal. That's going to be helpful later. And I say that because we can just substitute this into force friction equals mu force normal. And then because we already given that mu is 0.560 and force normal is F cosine 50 degrees, we can now say that force friction equals 0.56 times the force of cosine 50 degrees. All right. Now, it's time to substitute that in. Force sine 50 degrees obviously stays the same, plus what would be force friction, but again, from earlier, we substituted that in, plus 0.56 force cosine 50 degrees equals our force weight, which we solved for earlier to be 88.69 newtons. And we factor all that out, so that all we have left is a coefficient, and F equals 88.69 newtons. Plug all that into your calculator, and we get a force of about 78.765 newtons for number 2. Okay, let's move on to number 3. Okay, the problem reads 157 kilogram barrel needs to be moved across a warehouse. A force of 395 newtons is applied to the barrel to slide it across the tile floor. The coefficient of friction, aka mu, between the tile and barrel is 0.19. Calculate the net force acting on the barrel and its acceleration. And I know I have stupidly teeny tiny handwriting, but hopefully, let me adjust my light there. You can see it. I'll pause for a moment just so you can grasp and read it. Okay. All right. So first off, we need to draw a picture diagram. It's an object, and it didn't say how many degrees, so it's just flat on the floor on the surface, 157 kilograms. We draw our forces, force weight, obviously, which is just gravity pulling down, relative perpendicular to the surface, force normal, which is the opposite of that, which is perpendicular to the surface of contact, and force applied is 395 newtons, which for our reference, we're going to push it to the right. And force friction is pushing to the left. Remember, force friction is against force applied. Okay, we already know that force weight equals mg. Pretty straightforward, okay? Now, because from earlier, we already know that force normal equals force weight, we can say that we can plug our equation in 9.8 meters per second squared times the mass of our object, 157 kilograms, is equal to 1,538.6 newtons. Okay, and obviously we know that mu equals force friction divided by force normal. And mu is 0.19. And so we move Fn, we multiply each side by Fn. So it's Fn times mu equals force friction. And we get 0.19 times 1,538.6 newtons equals force friction. And the force friction is 292.334 newtons. And I forgot to put a negative there, but for our reference, it's over there. And the net force is force applied minus force friction. So I forgot to put the negative over there. But force applied, 395 newtons. We already know that. Minus 292.334 newtons. That's on total net force. Okay, and the first part said calculate the net force, which is 102.666 newtons approximately. But we're not done. It's also asking for our acceleration. Well, that's pretty straightforward. All we need to do is take the net force answer we just got and divide that by our mass of 157 kilograms, and our acceleration is about 0.6539 meters per second squared. Okay, number 4 is actually pretty straightforward because first off, we know that mu times F force normal equals force friction. But from problem number 3, the only thing that's really changed is the coefficient of friction mu, which is 0.79. But we just solved force normal in our previous problem. Again, the problem is the exact same, and we got 0.79 times 1,538.6 newtons, which is 395 newtons, minus 1,215.494 newtons. And that is equal to approximately negative 820.494 newtons. And keep in mind, this is the applied force is still the same, and this is force friction, which is 1,215.494 newtons. And we subtract that, we get negative 820.494 newtons, which in other words is telling us that we do not have enough force to get the object to start moving. And don't get deceived by this and think that the object is moving the opposite way. No. It's simply telling us that we do not have enough force to move the object. And because I said that, our acceleration is 0 meters per second squared. Okay, problem number 5, which should be familiar because we took a quiz on it. And the problem says, a car wrecker is lifting a 480 kilogram car straight up with a constant force of 7,531 newtons. Determine the acceleration of the car as it is lifted. Okay, our net force is 7,531 newtons. Keep in mind, this is not just 7,531 newtons pulling up, because, well, let me rephrase that. It's not just 7,531 newtons of just pure pulling up force, because we also have to take into account force weight. Okay? And we set up an equation of force weight plus force applied equals force net. How do you calculate force weight? Pretty straightforward. Typical force weight equals mg, 9.8 meters per second squared, times 480 kilograms, which is the mass of our object in this case. and we get 4,704 newtons. And the force net, which we are already given to be 7,531 newtons. And if you plug it into our equation, our applied force up is essentially 2,827 newtons. And it's asking us for the acceleration. So don't forget to divide that by the mass of our object, 480 kilograms. And you should get 5.889583 repeated meters per second squared. Okay, good there? Great. Okay, number 6. Determine the force of friction, in this case mu, if a 5 kilogram chair accelerates horizontally at 6 meters per second squared when pushed with a force of 40 newtons. What is the coefficient of friction between the chair and the floor? Okay, mu equals force friction divided by force normal. We already know that force weight equals force normal. This is pretty straightforward. You have the equation, plug it in, 5 kilos times 9.8 meters per second squared equals 49 newtons, which is our force normal. Now we need to find force friction. How do we find that? Okay, we know that the net force is 30 newtons because we have our acceleration of 6 meters per second squared, and we have our mass of 5 kilograms. Now 5 times 6 is 30, which gets us 30 newtons of net force. And force applied, which we were already given to be 40 newtons, and our force friction, which is pushing against us, that should equal 30 newtons. And so we have an equation of force applied minus force friction equals force net. 30 newtons is force net, and force applied is 40 newtons. Plug it in, you get force friction to be 10 newtons. So we already know, we just solved for force friction, and we found out what force normal is. In this case, it's just 10 divided by 49. Punch that into your calculator, and your coefficient, your force of friction should be about 0.2041. Okay, got it? Good. Okay, number 7. What is the drag force acting on a 56 kilogram skydiver if her acceleration is 6.7 meters per second squared? Determine her acceleration if she reaches terminal velocity. Okay, what I like to think about it is, first off, let's assume that there's no air resistance. What is the force of the skydiver if there is 0 air resistance? It's just force weight equals mg, right? 56 kilograms times 9.8 meters per second squared, which gets you 548.8 newtons. But obviously, her acceleration is not 9.8 meters per second squared, and there is air resistance, obviously. So we find just the speed of her right now. Force applied equals mg. Sorry, not mg, m times a. And 56 kilograms times 6.7 meters per second squared is 375.2 newtons. And because she lost some force, you could say, we need to calculate that loss, which is our force drag. And this is without air resistance, and this is what her current acceleration is with air resistance and all of the other factors into play. And we punch this into our calculator. Take this number minus this number, and we get our force drag of 173.6 newtons. And it also asks what's her acceleration during terminal velocity. We don't need to do any calculations on that because it says terminal velocity, and automatically from that, terminal velocity means you reached your max speed. So you're not accelerating, And our answer is 0 meters per second squared. Okay, number 8. You want to push a 75 newtons crate across the floor. What force is required to move the crate at a constant velocity if the coefficient of friction is 0.320? Okay, I know this drawing's a bit tiny, but that's number 8 right there. But, okay, what are we given? So first off, we know that mu equals force friction divided by force normal. And we plug that in because this is our mu, 0.32, which is given, equals force friction divided by 75 newtons, which again is our force normal. Because of that, we multiply that, and we find that our force friction equals 24 newtons. And we can set force applied equals force friction to get our answer of 24 newtons. Now you may be asking, why are we allowed to set force applied equals force friction? Because again, you want just enough force to get it moving. So just enough force, just enough applied force to get it moving, just to overcome our force friction. And thus, we get our answer of 24 newtons. And if it really helps you, you could think about our inclined plane lab when we were given just an object, the ramp, and a protractor to measure it. And if you remembered him explaining the force parallel and force weight, the force parallel and the force friction, they equal just enough each other to make it fall, which we get tangent theta to determine the coefficient of friction, theta in degrees. And if that helps you, that's how I got my answer of 24 newtons. Not a lot of solving, just don't overthink about this. All right, and we are at number 9. The problem is split into 2 parts. Calculate the tension in a rope that pulls a 124 kilogram sign up with an acceleration of 2.4 meters per second squared. Calculate the tension, part 2, which says calculate the tension in the rope if it is lowered at the same rate. Okay, first part. Calculate the tension in the rope that pulls the sign up at acceleration of 2.4 meters per second. So the sign is moving up, right? So I like to write force weight plus the force up equals the net force. And the net force, by the way, is just equal to force tension, to simplify that. Now, what's the force up? Like, essentially, what's mass times acceleration? If you punch that into a calculator, we find that it's 297.6 newtons. But keep in mind that's not the only force you need, because you also have to account, again, for the force to make it stay even and have the force up to make it pull up. And force weight equals mg, which is 124 kilos times 9.8 meters per second squared. Which would get our answer to be 1,215.2 newtons, which again, this is just enough force to make it even so that it doesn't go up or fall down. But we also can't forget our number that we solved for earlier. So we add the 2 numbers together and we get 1,512.8 newtons for the first part. Now, you have to be careful because now it's asking for the tension in the rope if it is lowered at the same rate. So in other words, you're just lowering the object at an acceleration of 2.4 meters per second squared. And the tension in the rope should be less because gravity is essentially helping it. And we have force weight minus the force down because like gravity is helping it equals the force net. And so we got force weight, which is 124 124 kilos times 9.8 meters per second squared. Again, we got this earlier of 1,215.2 newtons. And our force down, which is just this, 297.6 newtons. So in essence, part 2 of the problem is just this equation, except the plus is now a minus sign, which we get our answer to be 917.6 newtons for the second part of this problem. All right, now we are on to the last part of our problem, number 10, which, although it is quite wordy, it is actually not difficult at all, I promise you. And hold on, let me adjust this piece of paper. Okay, there we go. Okay, the problem is saying a team of dogs is pulling a sled and they drive up a hill in the Iditarod race in Alaska. The slope of the hill is 19 degrees from the horizontal. The dogs can will a constant force, which I think is a grammar typo, by the way, of 1,750 newtons parallel to the motion of the sled. The combined mass of the sled and driver is 262 kilograms, and the coefficient of friction, aka mu, between the runners of the sled and the snow is 0.290. Determine the acceleration of the sled as it is pulled up the hill. All right, again, we need to draw a diagram for this, which is shown right here. And we drew our diagram. We draw force normal, which is, again, perpendicular to our relative perpendicular to the point of reference. So force normal is there, and force perpendicular goes up. And this is our force parallel, which is pulling upwards. And this is our force friction, which is against us, which wants us to pull downwards. Now that we have written all of our forces in, we want to take a look at our givens. We know that force parallel is 1,750 newtons. And we don't know force friction. So first off, we need our helpful equation, mu equals force friction divided by force normal. We know that force parallel is, that is a perpendicular. Force normal, which is force perpendicular. Force normal, which is mg cosine theta. So force normal is mg cosine theta because, again, force normal is the equivalent to force perpendicular. And we get 262 kilograms times 9.8 meters per second squared times the cosine of 19 degrees. Punch that into your calculator. We get our force number to be about 2,427.713 newtons. And we already were given that mu equals 0.29. So we take the Fn and we multiply by Fn. So we get 0.29 times the force normal equals, 0.29 times force normal, which is approximately 704.0369 newtons. And this is, again, our force friction, okay? And force friction is mg sine theta, and force friction is and we plug all of those numbers in. We get force friction approximately equal to 835.9288 newtons. And then we get force friction plus force, losing my voice. Force friction plus force normal times 0.29 equals 1,539.9657 newtons. And so we get 1,750 newtons minus 1,539.9657 newtons equals 210.0343 newtons. That's our total net force. And you divide that by 262 kilos, which you get our acceleration to be about 0.8017 meters per second squared. And again, because the force of friction, because 0.29 times force normal equals 704.0364, we add, just to make this clear, again, we add them up, we add both of these up to get this force friction and also this force friction because of mg sine theta. So you're essentially adding two force frictions together. Again, 704.0369 newtons plus the 835.9288 newtons from mg sine theta. And we find out from this equation, force friction plus force normal times 0.29 equals 1,539.9657. And since our force parallel, this is wants to go up, that wants to go down, force normal minus force friction equals our total net force. That equates to 210.0343 newtons. And we divide that number by the mass of our object, which is 262 kilograms. And we get our answer of 0.8017 meters per second squared. I know I wasn't being that clear. But hopefully you understand this. Hopefully this is helpful. And that's all of the problems for homework number 4 on page 33.